So in this video, we're going to talk about how to solve systems of equations where you can use linear combination with multiplication. So remember that there are three ways to solve systems of equations. We already talked about graphing and substitution, and then in today's video, we're going to look at linear combination in a little bit more detail. So remember, in linear combination, we were taking two equations and adding them together, and then one variable was canceling out. So I just want to point out that you can't just always do this with a system. Like for example, in this system, if I go ahead and add the equations together, I end up with negative x plus 4y equals 10. Well, that's not an equation that's very useful to me because I cannot use it to solve for one of the variables. So what you have to do sometimes is multiply one or both of the equations by a number to make the coefficients of one variable equal and opposite. So for example, what would happen if I took that first equation, this x plus y equals 5, and multiplied it by 2? So if I did 2 times x plus y equals 5, remember I would distribute the 2 to every term in my equation. So that would give me 2x plus 2y equals 10. Well then if I combine that with the second equation, notice I would have something that I can work with, right? Because the 2x and minus 2x would cancel, and then I have 2y plus 3y, which is 5y, and that equals 10 plus 5, which is 15. So that is something that I can now use to solve and find the value of y. So we'll work on solving this equation a little bit later, but before we get to that, I just want to remind you to remember that a solution to a system of equations is an ordered pair. So remember, we're not just looking for an x value, we're also finding a y value, and we'll write our final solution as an xy ordered pair. And remember that when these values are plugged in, the x and y values will make both of the equations in the system true. So let's go back to this problem. So remember in this problem, I had multiplied this first equation by 2. So I had 2x plus 2y equals 10. And I had added it to the second equation, 2x plus 3y equals 5, which had given me the resulting equation, 5y equals 15. So now I can solve this equation for y by dividing both sides by 5. Right? When I divide both sides by 5, I end up with y equals 15 divided by 5, which is 3. So now what I can do is I can pick one of my equations to solve for x. So I'm just going to use the first equation. I'm going to use x plus y equals 5. I'm going to substitute in y equals 3, and I get x plus 3 equals 5. And now I'm going to subtract 3 from both sides, which gives me x equals 5 minus 3, which is 2. So I can write my solution now as an ordered pair, x comma y. So my solution will be 2, 3. So now let's try solving this system by linear combination. So remember, when we're doing linear combination, you want to first think about what would be the ideal situation. Like, what do I want my variables to look like? Well, what would be really nice is like if this first 5x term, if that was a 10x, right? That would be so much better, and I could go ahead and combine my two equations together. So I need to now figure out a way to turn this 5x into a 10x. So what I can do is I can go ahead and I can multiply by 2. Right? If I multiply that first equation by 2, I will actually end up with 10x. So that's actually exactly what I'm going to do. So I'm going to multiply every single term in the first equation by 2, which gives me 10x plus 2 times 7, which is 14y, equals 2 times negative 9, which is negative 18. Then I'm just going to recopy my second equation, right? Everything remains unchanged in my second equation. So 10x and minus 10x will cancel. 14y minus 6y is 8y. And then I have negative 18 plus 2, which is negative 16. So now to solve for y, I'm going to divide both sides by 8. So the 8's will cancel, and I have y equals negative 16 over 8, which is negative 2. So now what I can do is I can use one of my equations to solve for x. So I have 5x plus 7 times negative 2 equals negative 9. So when I simplify this, I get 5x plus 7 times negative 2, which is negative 14, and that equals negative 9. So we have 5x minus 14 equals negative 9. And then I'm going to solve this equation by adding 14 to both sides. And when I do that, on the left, I'm left with 5x equals negative 9 plus 14, which is 5. So 5x equals 5. I can now solve that equation by dividing both sides by 5, right? I'm going to divide both sides by 5, which gives me x equals 5 divided by 5, which is 1. So I have x equals 1, and then I have y equals negative 2. So my solution to the system of equations will be 1, negative 2. So when you solve by linear combination, we've been working with systems where you only have to multiply one of the equations by a number. Well, sometimes you'll actually have to multiply both of the equations by a number to make the coefficients equal and opposite. So when you do this, what you want to do is figure out what is the LCM of the coefficients of the variable you're trying to eliminate. So for example, in this problem, if I was trying to eliminate x, I would figure out the LCM of 3 and 4. Remember that LCM is the least common multiple, right? So you look at all the multiples of the two numbers and you figure out what is the least common one. So if you're doing 3 and 4, you would say, okay, the multiples of 3 are like 3, 6, 9, 12, 15, 18, etc. And then we'd say the multiples of 4 are 4, 8, 12, 16, 20, 24, etc. And then you'd look for the least one that's in common. So like 3 and 4, these are not common, but then you see 12 is the one that they have in common. So the LCM of 3 and 4 would be 12. Okay, so that's the number that we're going to need to use to figure out how to get these coefficients to cancel. So what you're going to do is you're going to multiply one or both equations by a number to get the two coefficients to be the LCM, but we need them to have opposite sign. Okay, so remember the two terms have to have opposite sign in order to cancel each other out. So let's look at this problem. If we were going to solve by linear combination, what you're first going to do is just say, okay, which variable do I want to eliminate? One clue that can kind of give you an idea is like if a variable already has opposite coefficients, that's kind of helpful. So like here, 3 and 4, they're both positive, right? So I may not want to do x. It is possible to do x, but you may not want to choose that. But if I look at y, notice that I have a plus 5y and a minus 2y. So if I figure out the LCM of 5 and 2, I can actually go ahead and multiply in a way to get these two terms to cancel. So the LCM of 5 and 2 is 10. So what I'm going to do is I want my top equation to be a plus 10y and I want my bottom equation to be a minus 10y. So I need to figure out how I can multiply these two equations by a number to get that to happen. Well, I can do that if I multiply the top equation by 2 and if I multiply the bottom equation by 5. So I'm going to take that top equation, I'm going to multiply it by 2. And remember when I do that, I distribute that 2. So that is going to give me 6x plus 10y equals 2 times 6, which is 12. Then I'm going to take 5 and multiply by that second equation, which will give me everything multiplied by 5. So I have 20x minus 10y equals 40. So now let's go ahead and put these two equations together. So I have 6x plus 20x, which is 26x. Plus 10y and minus 10y will cancel, and then I have 12 plus 40, which is 52. So now to solve for x, I'm going to go ahead and divide both sides by 26. And when I do that, I end up with x equals 52 divided by 26, which is 2. So now let's figure out what the value of y is by plugging into one of these equations. So I'm just going to pick the top equation, and there's really no reason I picked that equation except that it's just first. So I'm going to plug in 2 here for x, so I get 3 times 2 plus 5y equals 6. 3 times 2 is 6, so I have 6 plus 5y equals 6. So to solve for 5y, remember I'm going to start off by subtracting 6 from both sides, which gives me 5y equals 6 minus 6, which is 0. So if 5y equals 0, remember I'm going to divide both sides by 5, which gives me y equals 0 divided by 5, which is 0. So my solution is going to end up being 2, 0. So now let's try solving this system by linear combination. So once again, I'm going to kind of look for the variable that I want to eliminate. Well, I noticed that in my top equation, my x term is positive, and in the bottom term, it's negative. So I'm going to try to figure out the LCM of 4 and 10 so that I know what to multiply by. Well, if I list out the multiples of 4 and 10, the LCM is actually going to be 20. So my best situation would be if that top equation was a 20x and if that bottom equation was a minus 20x. So to get that, I'm going to go ahead and multiply this top equation by 5 because 5 times 4 is 20. And then the bottom equation I'm going to multiply by 2. So let's write out now our new equations by multiplying everything out. So I'm going to multiply everything up top by 5, which gives me 20x plus 5 times 2, which is 10. So 10y equals, and then we have negative 14 times 5, which is negative 70. My second equation, now I have 2 times negative 10x plus 7y equals negative 25. So when I multiply every single term by 2, I end up with negative 20x plus 14y equals negative 50. So now I'm going to go ahead and combine my two equations together. So 20x and minus 20x will cancel, and then I have 10y plus 14y, which is 24y. So I have negative 70 minus 50, which is negative 120. So now what I'm going to do is I'm going to solve this equation for y. So to do that, I'm going to divide both sides by 24. And when I do that, I get y equals negative 120 divided by 24, which is negative 5. So now I'm going to pick one of my equations and solve for x. So we have 4x plus 2y equals negative 14. I just picked the top equation. So I have 4x plus 2 times negative 5 equals negative 14. So I have 4x plus 2 times negative 5 is negative 10. That equals negative 14. So that gives me 4x minus 10 equals negative 14. So when I have 4x minus 10 equals negative 14, I need to first add 10 to both sides. And when I do that, I get 4x equals negative 14 plus 10, which is 4. And I need to divide both sides by 4 in order to solve for x. So that gives me x equals 1. So I have x equals 1 and y equals negative 5. So 1, negative 5 is the solution to this system of equations. So when you're solving by linear combination, you're going to first determine which variable you're going to try to eliminate. Then you're going to figure out what number you need to multiply one or both equations by to eliminate that variable. Then combine the two equations, solve the resulting equation for the variable that remains, and then plug this value back into either equation to solve for the value of the other variable. Remember that your final solution was going to be something like an x and a y. So your final solution is going to be an ordered pair with an x and y value that make both equations true.